Yeah, welcome back to next class. In the last class, already we covered some basics of organic chemistry, right? In this video lecture, we are trying to cover almost 5 to 6 concepts like what is the degree of unsaturation, fundamental meaning of degree of unsaturation, and how we are calculating by using different methods degree of unsaturation. Okay, right. Next, what about the homologous series and what are the conditions for homologous series, right? And what is the functional group, right? And what about the types of organic compounds and how to find hybridization of a given species, like in terms of sp hybridization, sp2 hybridization, and sp3 hybridizations. Okay, right. Now first we are going to start with degree of unsaturation, right? Degree of unsaturation, our first concept is degree of unsaturation. Degree of unsaturation, right? So what is the meaning of degree of unsaturation? Now to understand degree of unsaturation, first I am going to take now three compounds, alkanes, alkenes, and alkynes. One second, right? Here I am taking alkanes, next one alkenes, and third category alkynes. From that we can understand what is the exact meaning of degree of unsaturation, right? What is the general formula of alkanes? Now very well known that CnH2n plus 2, that is the general formula of alkenes. Okay, right. And what is the general formula of alkenes? CnH2n. And what is the general formula of alkynes? CnH2n minus 2. Okay, that is the general formula of alkanes, alkenes, and alkynes. So why we are writing general formula? What is the need of writing general formula to understand a degree of unsaturation? Yes, we have very good formula to calculate the degree of unsaturation, right? But just before going to calculate degree of unsaturation, we better to understand what is the exact fundamental meaning of degree of unsaturation. Okay, why? Because sometimes they are giving compounds like which of the following compound is unsaturated compound, something like that. Okay, there is a lot of difference between unsaturated compound and degree of unsaturation. Okay, so every pi bond containing molecules are not the unsaturated compounds. Somewhere we are expressing in terms of degree of unsaturation. Clear? What is the general formula of alkanes? CnH2n plus 2. General formula of alkanes CnH2n. And what is the general formula of alkynes? CnH2n minus 2. Okay, right. So if you want to tell degree of unsaturation, now compounds should be compared with alkanes. Why? Because what is the speciality of these alkanes? Alkanes are saturated hydrocarbons or unsaturated hydrocarbons. Alkanes are saturated hydrocarbons. Same point I am writing here. Alkanes are saturated. Alkanes are saturated hydrocarbons. Alkanes are saturated hydrocarbons. What is the meaning of saturated hydrocarbons? Right. Once again come back to same formula. What is the general formula? CnH2n plus 2. Yes, this is the general molecular formula of alkanes. Okay. And why we call them as saturated hydrocarbons? Now just you look at total how many number of hydrogen atoms are there on n number of carbon atoms. There are n number of carbon atoms, right? On n number of carbon atoms, maximum how many hydrogen atoms present? 2n plus 2 hydrogen atoms. That means once your compound is saturated hydrocarbon, right? In saturated hydrocarbon, maximum we can arrange how many number of hydrogen atoms on n number of carbon atoms? Maximum we can arrange 2n plus 2 hydrogen atoms on the n number of carbon atoms. Then your compound is said to be saturated hydrocarbon. Same point I am writing. Maximum yeah, maximum 2n plus 2 hydrogen atoms present on n number of carbon atoms. Maximum n number of carbon atoms. Okay, that is the meaning of saturated compound. Once again, you read the same statement. Alkanes are what type of hydrocarbons? Saturated hydrocarbons, right? What is the meaning of saturated hydrocarbon? Maximum 2n plus 2 hydrogen atoms present on n number of carbon atoms. More than that we cannot arrange. Okay, why? Because carbon valence is 4, and according to the general formula, maximum we can arrange now 2n plus 2 hydrogen atoms on the carbon atoms. Okay, now this is the saturated hydrocarbon. Saturated hydrocarbon. Clear? Saturated hydrocarbon. Yes. And come to this alkanes. Alkanes molecular formula, just you compare with alkanes. Here what is the molecular formula? CnH2n only, but not CnH2n plus 2. But in case of alkanes, CnH2n plus 2, right? Now in case of alkanes, how many hydrogen atoms are less when compared to alkanes? How many hydrogen atoms are less? 2 hydrogen atoms are less when compared to alkanes. In alkanes are 2 hydrogen atoms. In alkenes, in alkenes, two hydrogen atoms are less compared compared to alkanes. Compared to alkanes. Okay, and how many hydrogen atoms are less in case of alkanes? Again you compare with alkanes. Alkenes compared with alkanes, alkynes also compared with alkanes. Here how many number of hydrogen atoms are less when compared to alkanes? 4 hydrogen atoms are less when compared to alkanes. Okay, now come to this point. I am taking very simple example like CH2 hydrogen, and here CH hydrogen, next one CH3 or CH2 hydrogen. Let us take this compound. Now this is what we call alkane, and what is the general formula? CnH2n plus 2. CnH2n plus 2. Okay, for example, by the removal of two hydrogen atoms, just I am going to write two different products here. By the removal of two hydrogen atoms, okay, right. For example, if you are going to remove two hydrogen atoms from adjacent carbon atoms, then what is the result here? CH2 double bond CH and CH3. That is the compound. Okay, next one. For example, if you remove these two hydrogen atoms, now what is the compound formation? Cycloalkane. You observe these things. If you remove two hydrogen atoms from adjacent carbon atoms, you are getting this compound. And from first carbon and third carbon atom, if you remove hydrogen atoms, you are getting cyclic compound. Yes, it is unsaturated compound. First one. Why? Because what are the maximum number of possible hydrogens on n number of carbon atoms in alkanes? 2n plus 2. But here how many hydrogen atoms are present? Only 2n hydrogen atoms are present. There are 2 hydrogen atoms less when compared to alkanes. Now this compound is said to be unsaturated compound. Unsaturated compound. This compound is said to be unsaturated compound. Okay, unsaturated compound. Always you compare with alkanes. When compared to alkanes, that is unsaturated compound. Why? Because two hydrogen atoms are less when compared to alkane. And come to this one, here also two hydrogen atoms are less when compared to alkane, but this is not the unsaturated compound. Here we express in terms of degree of unsaturation. Now loss of one equivalent of hydrogen will produce degree of unsaturation 1. Here we can write like this: degree of unsaturation equals to 1. Same point I am writing here. Loss of H2 gives degree of unsaturation equals to 1. Loss of H2 gives degree of unsaturation equals to 1. Degree of unsaturation nothing but du equals to 1, nothing but here two possibilities are there. Du equals to 1 means that may be pi bond or that may be ring. That may be ring. Very important point. Degree of unsaturation or double bond equivalence, both one are same. Degree of unsaturation equals to 1 or double bond equivalence equals to 1, nothing but now here there may be presence of pi bond or one ring system, that may be 3-membered ring, 4-membered ring, depending on the given situation. Okay, now here du equals to 1 nothing but 1 pi bond and 1 ring, right? Now same points I am writing here. Degree of unsaturation equals to 1. Then what are the possibilities? If degree of unsaturation equals to 1, then what are the possibilities? Now these are the possibilities. One second, right? First point, uh, du equals to 1 nothing but du equals to 1 means pi bond or 1 ring, pi bond or ring, that is the combination, either 1 pi bond or 1 ring. For example, second point, if degree of unsaturation equals to 2, then what is the situation? If du equals to 2, du equals to 2, then 2 pi bonds, 2 pi bonds are pi bond plus ring, pi bond plus ring, pi bond plus 1 ring, pi bond plus ring, or what is the third possibility? Third possibility is 2 rings. Third possibility, 2 rings or 2 rings. Remember these points. Okay, so that is the way of expressing that degree of unsaturation once du equals to 1. What is the meaning of du1? That may be pi bond or 1 ring. Du equals to 2 nothing but 2 pi bonds or 1 pi bond plus 1 ring or 2 rings. Okay, right? For example, any type of compounds are what given, then how we are calculating degree of unsaturation? Okay, here two possibilities are there. Sometimes directly they are giving structure. If structure is given, yes, we can easily find out the degree of unsaturation. Sometimes they are giving molecular formula. By using molecular formula also we can calculate the degree of unsaturation. First let us try with the compound. One second. Yeah, for example, compound is given like this, CH3, CH double bond CH2. Very simple examples I am taking that. Next one, this is the given molecule. Yes, here triple bond is given. Next here I am taking like this, double bond, again same double bond. Here double bond. Next some ring system is given. Next one here I am taking like this, double bond. Here also same double bond, but here some ring system is given like this. Then how to find out degree of unsaturation? Here structures are given. Once structures are given, if structure is very clear, then simply you find out number of pi bonds and number of rings. Now this one contains how many number of pi bonds? Now only one pi bond is present. Then what is the degree of unsaturation? 1. Okay, next one, second example, how many pi bonds present in the given compound? 2 pi bonds are there. Then what is the degree of unsaturation? 2. In the third example, how many number of pi bonds present? 1, 2, 3 pi bonds are there. Then what is the degree of unsaturation? 3. Okay, right, degree of unsaturation 3. Come to the fourth example, how many pi bonds present? 1, 2, 3. Directly degree of unsaturation equals to 3. Yeah, here one pi bond is present. Next one ring is present. Pi bond and ring is present. Okay, right, then what is the degree of unsaturation? 2. Here how many pi bonds and how many rings? 2 pi bonds and 1 ring is present. Then what is the degree of unsaturation? 3. So that is the simple way of calculating degree of unsaturation whenever the compound is given, if structure is very clear without any confusion. Once again you remember this point, if your compound is very clear, that means you can easily find out number of pi bonds and number of rings, then directly you can write degree of unsaturation. If any complicated structures given, then we will see how to calculate degree of unsaturation, right? For example, this is the given compound. Yes, very clear structure. For example, aromatic rings are what given like this. Yeah, outside the ring system double bond, here something like C double bond O, H is given. Somewhere here I am writing carboxylic acid OH. This is the another structure. Okay. Next one, if compound is given like this, yeah, phenyl ring system. I am not going to write resonance forms. Resonance hybrid I am not taking. Why? Because till now resonance is not completed. That's why clear Resonance structures I am not I'm taking, but not the resonance hybrid. That's why clearly I am going to write pi bonds here. One more phenyl ring I am connecting like this, right? Next one here also same phenyl ring system. Here somewhere double bond is given. Next one here C triple bond N is given. Next one C double bond O H. Any type of molecule is given. Okay. Next one here another simple example, phenyl ring system is given. Next one here also phenyl ring system. Okay, here double bond. Next one right side here I am taking like this extra, here methyl group is given. Anything no problem. Here something like C double bond O H is given. Then how to find out degree of unsaturation, right? Now according to that first structure given molecule, very clear. So pi bond is present, pi bond ring again ring. What is the degree of unsaturation? Now compound is very clear. We can easily identify number of pi bonds and number of rings. Then what is the degree of unsaturation? 4. And come to next example. Here also your compound is very clear, no confusion. Here how many number of pi bonds present? 1 2 3 4 5 6. 6 pi bonds are there. Plus how many rings present? One ring is present. Now 6 pi bonds plus one ring system. Then what is the degree of unsaturation? 7. Clear? Come to this example. How many number of pi bonds are what present? First of all, here two pi bonds are there. In this C triple bond N, there are two pi bonds. 2, next one 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 pi bonds are present. And how many rings? 1, 2, 3. 13 plus 3. What is the degree of unsaturation? 16. Okay, right. Come to this example. Again, very clear structure is given. We can easily identify number of pi bonds and number of rings. Calculate degree of unsaturation. What is the degree of unsaturation of this molecule? First to find out number of pi bonds. 3 plus 3, 6, 7, 8, 9, 10. 10 pi bonds are there. Once again, 3 plus 3, 6, 6 plus 3, 9, 10, 11 pi bonds. Okay, 11 pi bonds and how many rings? 3 rings. 11 plus 3. What is the degree of unsaturation? 14. That is a way of calculating degree of unsaturation whenever clear structure is given. Yes. Come to second possibility. Now, whenever molecular formulas are given, then how to calculate? Why? Because we don't know exact structure. Then how we are calculating degree of unsaturation? For that, here I am going to write first formula. Actually 2-3 methods are there. So now according to your conveniency, you can use the method. Now first one, most convenient formula I am giving here. Now note this formula, that is degree of unsaturation or double bond equivalence. Double bond equivalence. Degree of unsaturation or double bond equivalence equals to, very clear formula is there. Now number of carbon atoms plus 1. See nothing but number of carbon atoms minus monovalent atoms. Number of hydrogen atoms plus halogen. These two are monovalent. And nitrogen is trivalent by 2. That is the formula. Now note down this formula. Very important. Yeah. This is very simple formula to calculate a degree of unsaturation when molecular formula is given. Okay. Degree of unsaturation or double bond equivalence equals to number of carbon atoms plus 1. See nothing but here number of carbon atoms, number of carbon atoms minus number of hydrogen atoms plus number of halogen atoms minus number of nitrogen atoms by 2. Okay, note down this formula. Yes, I am going to give one general formula like this. C8 H8 is given. C8 and H8 is given. We don't know about the structure of that compound. Okay. Then how to calculate the degree of unsaturation by using that formula, right? Degree of unsaturation du equals to, apply formula, number of carbon atoms plus 1 minus number of hydrogen atoms plus number of halogen atoms minus number of nitrogens by 2. So that is the formula. Okay, right. Now just you substitute number of carbon atoms. How many number of carbon atoms present? 8 carbon atoms are there, minus how many number of hydrogen atoms? 8 hydrogen atoms present, no halogen and no nitrogen, divided by 2. So 9 minus 2 4 jar 8. So 4. What about degree of unsaturation? 5. Very simple example, C8H8, its degree of unsaturation equals to 5. Okay. Now just to observe this one, the about the convenience of this formula, right? For example, compound is given like this. Yeah, this is the given compound. So clearly I am going to write along with carbon atoms. Very important example. Okay. Here first I am going to take carbons like this. Observe this one very carefully. Now carbon, 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 again carbon. Yes, 4 carbon atoms I am selecting. Next one here, again 4 carbons, 1, 2, 3 and 4. Okay. So totally how many carbon atoms we are selecting? Yes, 8 carbon atoms we are selecting. And how I am going to connect? Now just you observe this one, CC bond, CC bond, CC bond, again CC. Next carbon carbon bond, CC bond, CC bond, again CC. Okay. Even though there is a cross, here no carbon atom is present. Very important. Here also no carbon atom is present. Totally how many carbon atoms present? 8 carbon atoms are there. And further CC bond, CC, CC, again CC. Right. Now here this one related to C8H8. What is the name of this molecule? This is called cubane. Okay, cubane. In solid state, now we are taking it as cube. In mathematics also cube, but here cubane. In chemistry that is known as cubane. C8H8, cubane. Now here on each carbon atom, how many hydrogen atoms should be present? Only one hydrogen. Why? Because what is the valency of carbon atom? 4. That fourth valency is satisfied by hydrogen. Okay, hydrogen. Here also same thing. Hydrogen, hydrogen. Yes, hydrogen, hydrogen. Next one, hydrogen. Totally how many hydrogen atoms present? 8 hydrogen atoms. Now this is our molecular formula, C8H8. For example, if compound is given like this, instead of giving, once again you observe cubane molecule, then I am going to give question. Cubane, what is the molecular formula? C8H8. Yes. For example, these are the two different types of questions they are asking. Yes. You observe this one. They are giving cubane formula, cubane structure by using 8 carbon atoms and 8 hydrogen atoms. Yes, just I am connecting like this, CC bond, CC, clear. This is the cubane molecule. Okay, same as previous, same cubane. Here I am taking, for example, this is the given compound, only they are giving like this, and they are asking what is the degree of unsaturation. What is the degree of unsaturation? Structure is little bit complicated, not like previous. In the previous examples, very clearly mentioned that phenyl group, double bond and rings, something like that. But here little bit complicated. In that case, just you find out number of carbon atoms here. How many carbon atoms present? 8 carbon atoms. And how many hydrogen atoms present? 8 hydrogen atoms. Why? Because according to the carbon valency, on each carbon atom, how many hydrogens present? One hydrogen present. That's why I am taking C8H8. Then directly apply this formula. degree of unsaturation equals to, what is the formula? Number of carbon atoms plus 1 minus number of hydrogens plus number of halogens minus number of nitrogens by 2. Here there is no halogen and no nitrogen, that's why number of carbon atoms 8 plus 1, number of carbons plus 1 minus how many number of hydrogens? 8 by 2. If you simplify this one, finally you are getting 5. Okay, that is the use of formula. Whenever complicated structure is given, from that just you identify number of carbon atoms and number of hydrogen atoms, or if halogens, nitrogen, anyone is present. For example, oxygen atoms are present, there is no need to consider. Why? Because there is no number of oxygen atoms in the formula. This formula is sufficient for any kind of molecule. Okay, right. So this is the degree of unsaturation, what is 5. And same question they are asking like this, by second type of question, breaking by breaking of same compound, by breaking of how many, by breaking of how many how many cc bonds, how many cc bonds, by breaking of how many cc bonds, open chain open chain compound is formed. By breaking of how many cc bonds open chain compound is formed. This type of question also very important. For example, simple cyclopropane, cyclobutane, cyclopentane and cyclohexane is given. Very simple examples is given, right? Just by breaking of one cc bond, what we are getting? Open chain compound. If simple example is given, there is no problem. But whenever this complicated structure is given, and this is the question, what is the question here? By breaking of how many pi bonds, sorry, how many cc bonds, open chain compound is formed. In that case, simply you calculate the degree of unsaturation. What is the degree of unsaturation? 5. That means we will get we will get we will get open chain open chain compound open chain compound by breaking 5 cc bonds. That is the answer. Okay, if you start breaking, you will get confusion. Okay, we are not getting the exact and perfect answer, right? So in that case, just you do like this, calculate the degree of unsaturation. If degree of unsaturation equals to 5, nothing but by breaking of 5 bonds, finally you are getting open chain structure. Okay, right. Now let us calculate one more example, that C60. What is the degree of unsaturation? Very simple. Degree of unsaturation equals to, simple carbon atoms are there, 60 plus 1 equals to 61. That's it. Okay, right. For example, some other benzene rings are given as like this. Naphthalene molecule is given. Then what is the degree of unsaturation? Okay, to calculate the degree of unsaturation, directly find out the number of pi bonds and rings. Now how many pi bonds are there? 5 pi bonds are there, plus how many rings? 2 rings. Then what is the degree of unsaturation? 7. That is very convenient formula, right? For example, question is given like this: naphthalene molecule, sorry, anthracene molecule, 3 phenyl rings are given like this. 3 phenyl rings. Yes. Here, how to calculate degree of unsaturation? How many pi bonds are there? 3, 4, 5, 6, 7. 7 pi bonds, and how many rings? 3 rings are there. 7 plus 3 equals to 10. That is the degree of unsaturation. 1, 2, 3, 4, 5, 6, 7 pi bonds. Number of rings equals to 3. Then what is the degree of unsaturation? 10. Okay, right. For example, unfortunately, if they are giving very lengthy compound, just I am giving only one example. Somewhere I am writing. Okay. This is the given compound. Find out degree of unsaturation, right? Here three different methods I am giving according to your conveniency. Now you can use that formula. Now what is the first formula? What is first formula I am going to use? Now that is same as previous. What is the formula? Number of carbon atoms. Degree of unsaturation equals to degree of unsaturation, du equals to number of carbon atoms plus 1 minus number of hydrogen plus halogen minus number of nitrogen by 2. Okay, that is the formula. Then here this compound contains total 30 carbon atoms. How to count number of carbon atoms? Like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Total how many carbon atoms? Yes, there are 30 carbon atoms plus 1 minus count number of hydrogen atoms by 2. How many number of hydrogen atoms? According to the carbon valency, we are not going to take hydrogen atoms at junction of carbon atoms. Just we are taking here hydrogen, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Total how many hydrogen atoms present? 14 hydrogen atoms. That I am writing here. Okay. 30 plus 1. 31 minus 7. What is the answer? 24. That is the degree of unsaturation. Yes. Okay. That is the degree of unsaturation. For example, if you want to calculate by other method, second method. So what is the second method for calculating degree of unsaturation? So according to this one, what is the molecular formula of the given compound? Molecular formula of the given compound equals to C30H14. Okay, that is the given molecular formula. For example, if you want to use any second method, now this is the molecular formula. Okay, after getting this molecular formula, for example, if it is alkane, here I am taking like this C30H14. If it is alkane, for 30 carbon atoms, by applying CnH2n plus 2, how many hydrogen atoms should be present if it is alkane? Why? Because startingly I already explained very clearly that degree of unsaturation always compared with what? Alkane. Okay, with 30 carbon atoms, what is the molecular formula of alkane? H2n. 2n nothing but 2 into 30, 60 plus 2. How many hydrogens should be present? 62. Okay, in the next page I am calculating very clearly. For example, if it is alkane, this is the formula 62. If it is alkane. Now in the given compound, how many carbon atoms present? 30 carbon atoms. And how many hydrogen atoms? 14 hydrogen atoms. Okay. Now C30H14. C30H14. Okay, na? Right. Now just you calculate difference in hydrogen atoms. I am writing like this: delta NH. What is the meaning of delta NH? Difference between hydrogen atoms. Here 62 minus 14. 62 minus 14. How many hydrogen atoms? 62, 14. 8 and 4. Yeah, 48. Okay, na? First you calculate difference between hydrogen atoms. After that, now you apply this formula. Degree of unsaturation equals to delta NH by 2. Direct formula, delta NH by 2. So 48 by 2 equals to 24. Yes, that is the degree of unsaturation. Same value you are getting here. Best you look at this one. Yeah, according to this formula. Now what is the degree of unsaturation? 24. This is the first method, but in general I prefer only this method. Okay, so very convenient method. Just you find out the number of carbon, hydrogen, halogen and nitrogen, directly you will get degree of unsaturation. Otherwise, for example, if you want to calculate by using what second method, just you count number of carbon atoms and number of hydrogen atoms. With these carbon atoms, same formula you write in the form of alkane. After writing that, just you calculate number difference between hydrogen atoms. Here 62 present, here 14 present. 62 minus 14 equals to 48. After getting this value, directly degree of unsaturation equals to delta NH by 2. Okay, this is the second method. Otherwise, what is the third method? For example, if you want to calculate by this method, here C30 H 62, right? And what is the molecular formula of given compound? C30 H14. Clear? Now, in this compound, total how many carbon atoms present? Yes, 13 carbon atoms are there. Now, degree of unsaturation nothing but we want number of pi bonds and number of rings. To calculate number of pi bonds, equals to number of carbon atoms by 2, that is equals to 15. What is the meaning of 15? In order to arrange pi bond is arranged between two carbon atoms. Okay, so for example, if you are having 30 carbon atoms, to arrange pi bond between two carbon atoms, we require how many carbon atoms? 15 carbon atoms. Now here in this method, number of pi bonds equals to number of carbon atoms in the given compound by 2, you are getting 15. Okay, next one. Calculate the number of rings. In the given compound, how many number of rings present? 3, 4, 5, 6, 7, 8, 9 rings are there. Okay. In the given compound, number of rings equals to 9. Number of rings equals to 9. And already we know that what is the formula for degree of unsaturation? Number of pi bonds plus number of rings. Number of pi bonds plus number of rings. Then what is the answer? 15 plus 9 equals to 24. These are the three different methods to calculate degree of unsaturation. Okay. Yeah. Come to again same page. Here first we are calculating on the basis of simple formula, number of carbon atoms plus 1 minus number of hydrogen plus halogen minus number of nitrogen by 2. Here number of, oh, 1 second. Yeah. क्या हुआ? No problem. Here number of halogen equals to 0. Number of nitrogen equals to 0. So finally you are getting 24. And what is the next method? Find out the molecular formula of the given compound, and that molecular formula you compare with alkane by using same number of carbon atoms. First to find out difference between hydrogen atoms. After getting that value, delta NH by 2, finally you are getting degree of unsaturation. Otherwise, if there are 30 carbon atoms, calculate number of pi bonds equals to number of carbon atoms by 2. You are getting 15. And directly just by looking at the molecule, you can calculate number of rings. So finally, number of pi bonds plus number of rings equals to 24. 15 plus 9 equals to 24. Okay. So this is the story about degree of unsaturation. So first point, what is the degree of unsaturation? So we are comparing with alkanes. Okay, alkane is the saturated compound. Why it is saturated compound? So what are the maximum number of hydrogens present on given n number of carbon atoms? 2n plus 2 hydrogen atoms. For example, on the same number of carbon atoms, if 2 hydrogen atoms are less, those are known as alkenes, unsaturated hydrocarbons. Next one, if 4 hydrogen atoms are less when compared to alkanes, Those are also unsaturated hydrocarbons. Those are known as alkynes. Okay. Now, whenever number of hydrogen atoms are less when compared to alkanes, that is expressed in terms of what? Degree of unsaturation, and we are calculating like this. Okay. This is a story about degree of unsaturation, right? Next one. Already 40 minutes completed. Okay. Next. After completion of degree of unsaturation, I am going for functional group. So very clearly I am discussing each and every point. Next I am going for functional group. Functional group. What is the meaning of functional group? Yes, this is also important, right? What is the meaning of functional group? For example, so whatever the compound given, somewhere here C double bond OH is there, carboxylic acid. Now once if you are doing reaction with something like sodium, now who is reacting with sodium? So what you are getting in this compound? So from that compound, okay, C double bond O minus and Na plus is connected to this oxygen atom. That is the compound you are getting. That means sodium salt of carboxylic acid. So whatever the segment present in this molecule, this is the segment containing COOH, that is responsible for chemical reactions, but not the other part of the molecule. Okay. So whichever segment is responsible for chemical reactions, that part is known as functional group. Same definition I am writing here, that the segment the segment the segment which is responsible for segment which is responsible for chemical properties are is known as, one second, yes, once again I am going to repeat same point. The segment which is responsible for chemical properties is known as functional group. Functional group. Okay, that is the meaning. For example, alcohols are given, OH is responsible for the chemical properties, carboxylic acid is given, COOH part is the responsible for chemical properties. Okay, so if you want to define functional group, now this is the definition. If any compound is given, now the segment, okay, whatever the segment, here I am taking carboxylic acid, the segment which is responsible for chemical properties is known as functional group. Okay, right. Here I am going to write some known functional groups, right? What are the different types of functional groups I am going to write? First I am taking this C double bond OH. What is name of this particular segment? That is taken as acid. Okay, again in IUPAC, again I will repeat, no problem, but at least minimum names are required. Even further we are going to define that homologous series, there also some conditions are required. What are the conditions for homologous series? General molecular formulas, general function, molecular formula should be same, functional group should be same, something like that. Okay, that's why before going to homologous series, just I am giving fundamental definition for functional group. Yeah, this is carboxylic acid, right? Next one, here some other functional groups I am taking like this, ding ding. Yeah. Next one, after acid I am taking like this, C double bond O R. What is name of this functional group? Ester. Next one, C double bond OH. What is the functional group? Aldehyde. You know very well about these functional groups. Now this one is called as ketone. For example, C double bond O, X is given acid halide. acid halide. Okay, acid halide. Next, another one, C double bond O, O C double bond O. This one, acid anhydride, acid anhydride. For example, Cn is given. What is the name of this functional group? Cyanide. Just normal names we are writing. I am not going to that IUPAC nomenclature. So is it visible? Cyanide. Yeah, okay, no problem. Cyanide. Next one, OH. Now this is hydroxy. Otherwise, I am writing alcohol. Alcohol. For example, SH group is given. That is thioalcohol. Thioalcohol. Thioalcohol acid amide completed, not completed. Okay, C double bond O N something. Okay, this one will take later. Why? Because there are primary, secondary, and tertiary amides. Okay, alcohol and thioalcohol completed. And for example, NO2 is given. This one, nitro, ONO is given. Nitrite, nitrite. Next one, halogen. This is also considered as functional group. Don't get confusion because of showing different properties than alkanes. Okay, so that is also taken as what? Functional group. But actually in IUPAC nomenclature, now secondary suffix is not given for halogens. Halogens always considered as substituents. That is a different situation. But halogens are also considered as functional group. Next one, nitrate completed. For example, C double bond something like NH is given. These are known as imines. Next one, C double bond NOH. Oxime, oxime. Something like this one given. Ether, ethers. For example, sulfur linkage is given. Thioether, thioether. For example, C double bond C is given. Alkene, alkene. C triple bond C is given. Alkyne. Okay, these are the some important functional groups. Okay, here I am taking like this, NH2 NH N. Okay, what is NH2? 1 degree amine, 1 degree amine. This one 2 degree amine. Next 3 degree amine. What is the speciality of these functional groups? 1 degree amine, 2 degree amine, 3 degree amine. These are considered as different functional groups. Okay, now acid, ester, aldehyde, ketone, acid halide, acid anhydride, cyanide, alcohol, thioalcohol, nitro, nitrite, halogen, imine, oxime, ether, thioether, alkene, alkyne, primary, secondary, tertiary amines. 1 degree amine, 2 degree amine, 3 degree amine. Okay, right. One second. Okay, no problem. Yeah. For example, C double bond O NH2 is given. C double bond O NH given. C double bond O N is given. These three also very important. Just like amines, these three also very important. Okay. Now, what about this one? Primary acid amide or primary amide. Primary amide or 1 degree amide. This one 2 degree amide. Next 3 degree amide. These three are considered as different functional groups. Different functional groups. Very, very important. Yes. Next and most important point. already I covered in the previous lectures. Okay, what are these two compounds? Very important point. Yeah, OH, OH and CH3. These two are same functional groups or different functional groups. Very, very important point. Here, what is the difference? OH is directly not connected to the ring system, but here OH is directly connected to the ring system. They are having same molecular formula, but these two are considered as two different two different functional groups. Two different functional groups. Now this is a story about the functional groups. Okay, in the next lecture, now we will try to finish what about calculation of hybridization, homologous series and types of now hydrocarbons in terms of open chain, cyclic compounds, aromatic compounds, something like that. Okay, so that we will finish in the next class. Okay, thank you.